This thing here is called an Atwood machine. It was invented by George Atwood in 1784 for the study of constant acceleration motion. So here you have a pulley, two boxes attached by a string, and the string hangs over that pulley. In this case, the two boxes, they have different mass, which means if you release this system from rest, this heavier box is going to go down and the 1 kilogram is going to go up. So the system will start accelerating, and what we want to find is the tension in the string and the acceleration of the 4 kilogram box. Of course, now we're going to say the tension is the same throughout the string. In order for us to be able to say that, we have to pretend that the string is massless. The pulley is massless and there is no friction at the pulley. Under those three conditions, we can have the tension being the same throughout the string. Now see if you can find the tension and the acceleration. So again, let's follow the problem-solving procedures. The direction for acceleration. Now these two, they have different direction for acceleration. This one accelerates downward, and that one accelerates upward. Let's see, for this one, I'm drawing a dot for the 1 kilogram. There is the non-contact force mg, which is 10 newtons. This box is touching the string tension. A tension can only pull, so it pulls upward. For the 4 kilogram box, you also have an mg that will be 40. It's touching that string, so you have a tension going up. Those two, they're the same T. Same amount of tension because it's the same string. Now let's write the net force equals to ma because they're not touching anything else, so we're done with the force diagram. For the 1 kilogram box, the acceleration goes up, so the upward force is bigger than the mg. So we use the bigger side minus the smaller side. T minus 10 equals to ma. For the 4 kilogram box, the downward force has to be the bigger one. So it will be the 40 minus t. And that equals to ma. Again, you can solve them any way you want, but if you stack them together, the internal force tension, see this tension is between the two boxes. The internal force tension would cancel again. In fact, if after you stack them and add them together, you find that the tension, they either both positive or both negative, so they don't cancel. That means something is wrong. You got to fix your equation. Right now they cancel, everything's okay. 40 minus equals to 1 plus 4 times a. So it's 30 equals to 5a. The acceleration will be 6. To find tension, just plug it into one of those two equations, and you will find the tension to be 16 newtons. Again, this equation right here is the equation for the whole system. See, if you had looked at the whole system, you would see that on this side you got 10 newtons pulling, this side it's 40 newtons pulling, so 10, 40. Even though they both go downward, but because of the string bends, they are actually working against each other. So 40 and 10, we have to do the bigger side minus the smaller side to find the net force. Since we're looking at the whole system, the mass is 1 plus 4, 5 kilograms. So if you just write the force equation for the whole system, you'll be able to find the acceleration right away, 6. And then you just pick one of those two to write, then you'll be able to find the tension.